Hey guys, this is Mike. Today I'm going to go over a problem from the textbook that has to do with subproofs. We're just going to work the problem, and it will kind of be like a demonstration of how to use subproofs. In this one specifically, the way I solve it, you use a horseshoe out and an indirect proof. So it'll be a good example of both the types of subproofs that we've learned. So I think it'll be a good problem to work. Of course, there's probably different ways to do it, but I'm just going to show you the way I do it. So great. So first you'll notice we've got 4 assumptions here at the top that the problem gave us. B horseshoe, F and G, like horseshoe D, C horseshoe D, horseshoe not A, not F, horseshoe D and E, not G, horseshoe not B. So fairly complex, a lot of different atomics. And our answer, our conclusion we need to get out of this is not A and not B. So working backwards, we need to unlock this because it's an and behind a not, so it's actually something else, so we want to see what we're looking for. So you can do going backwards, and horseshoe exchange to get A, horseshoe not B. And this is what I'll use. You could also have used De Morgan's to get not A or not B. And you could have tried to solve for one of the sides, like not A, for example, and done an indirect proof, and then you could have done RN to get not B and gotten your answer. That's another way you could try to do it, but I'm just going to do this way. Neither one is wrong, but yeah. So we'll set up our subproof for horseshoe out. So if we want to get, for horseshoe in. So if we want to get this horseshoe, we'll start with A and end up with not B. So we've assumed A. And if we can get not B out of that, we'll have A horseshoe not B, which is the same thing as our conclusion, not A and B. So brilliant. So let's see what we can do. So first you'll notice we have A. That means we can do modus tollens on line 2 to get not C horseshoe D. And then we can do and horseshoe exchange to get C and not D, which is like the same thing we've done below. And horseshoe exchange in line 6. And then we can split that up using and out to get C and not D. Okay, brilliant. So far so good. So we've got C and not D. What else can we do? Well, if we want to be really cool, we can make an RN, not D, or not E, because of course it's the magic rule. Since we have the not D, we can RN that with anything. But we're doing it with not E, because then we can De Morgan's that and get not D and E, and use that De Morgan's to modus tollens. We've got the opposite of D and E, which means we can get the opposite of not F. Using modus tollens again on line 3 and 11. Okay, so this is where I would be stumped with our normal rules while working this problem. We've got a few atomics. We've got F, we've got not D, we've got C, we've got A, but we've already gotten the D and E out of this, or we've already used this to get the F, so that one's done. We've already used this to get the C horseshoe D. We've already unlocked those. Those are like done with. We're trying to either get something out of this to try to get not B, like if we could modus tollens that and get not B, that would be great. Or if we had not G, we could also get not B. So we have 2 ways we can get not B, but as you can see, we don't have a G, we don't have any way of getting the G, so we're stuck a little bit. But you can just make an indirect proof to assume B. And if we get a contradiction, we get not B, and then by using an indirect proof within our horseshoe in, then we'll get our answer. So, and now we've got plenty to work with. So we've got B, that means we can do modus tollens to get G. Modus tollens lines 4 and 13. This is an assumption for not out, because we're getting a not. sorry, for not in, because we're adding it on. And that's one of the indirect proofs. So we've got G. We can also use B to do modus ponens. And what do we get out of that? We'll get F and G biconditional D, modus ponens, line 1, 13. Great, and now we're moving. We've got more stuff we can do even. We can biconditional out that to get F and G horseshoe D and the opposite. Or not the opposite, but the reverse order of it. So that's biconditional out, line 15. Biconditional out, line 15. Okay, so now we've got a few things to work with. So we want to get the D out of here. So you see we've got G and we've also got F on its own, so we can do an and in, get F and G, F and G, and now with F and G, modus ponens, we'll get D, 19, so this is and in lines 12 and 14, and that is modus ponens on line 18, 16. 18 and 16. Just so you can see the numbers I'm writing, sorry. Didn't realize you couldn't see. Okay, so now with line 20, you see we've got D here, and we've got not D here. So that's a contradiction. So we can bring not D in. We can always bring something from outside of the proof, subproof, into the next level. We can't do it the other way, but we can do it this way. So we'll bring not D in, and then we can make D and not D, which will be and in lines 19 and 20. I mean, we didn't even really need to bring this in. We could just, we didn't need to write it. Just an automatic, I just put the extra stuff in there, no harm. But anyway, so yeah, that's our contradiction. So we assumed B, we got a contradiction. Brilliant, which means we've got a not B out of that. So this is line, say, 22. Line 22, we've got a not B out of it. That's not in lines 13 through 21. Sorry, 13 through 21. So now that we've got the not B out of that, you can see how we started with A and ended up with not B. That means we can close this subproof off as well. We assumed A, we got not B. That means we can use horseshoe in. Say A horseshoe not B, and that's horseshoe in lines 5 through 21. And now, like we were doing backwards, so if we and horseshoe exchange that, we'll get not A and B. So great, so we started with our assumptions. We started seeing that we needed to get a horseshoe. So we set up a horseshoe in, starting with the antecedent, and see if we can get the, seeing if we can get the consequent out of it. And then, while working through the not in, the subproof, we saw that this would be so much easier if we could do an indirect proof. So we just do an indirect proof within that other subproof, get what we want out of here, and bam, we've done the problem. So that is a demonstration of how to do subproofs, indirect proof and not in, and I hope you've learned something. Thank you very much, and you have a lovely day. Goodbye.